Today we're learning how to write linear equations from context, which is to say real world problems. And we're going to use graphs to graph and to show what's going on in that situation. So when we think of the y-intercept and slope for our linear equations in context, we think of them a little differently because we actually are thinking of them in a situation. We're going to think of the y-intercept as the starting point. This is also called the initial value. Sorry, that's a typo. Initial, remember, like your initials are the first letters of your name. Initial just means to start. So it literally means starting point. We are going to refer to the slope as the rate of change. So we usually, when we're just looking at a graph, we'll always talk about them as slope and y-intercept because those are very visual and easy to tell. But starting point and rate of change work a little better in scenarios. So we're going to go to this scenario, and it says to identify the starting point. Remember, the starting point is the y-intercept, or what y is when x is 0, and the rate of change is the slope. So those are synonymous, but it makes more sense for these words when we're talking in our scenario. Fill out the table, create a graph, and write an equation. It says a Salt Lake City taxi service charges an initial $2 flag drop fee. That just means as soon as you get in the car. It always costs $2 to start. Plus an additional $1.50 per half mile. So you pay $2 to get in the car and then $1.50 to go somewhere that's half a mile away. And then $1.50 for every half mile after that too. Let x represent miles and y represent cost. Then write an equation to figure out how much x miles will cost. Be careful, label and scale your axes appropriately. So our starting point, I'm going to make the table first with this. I find that that's really helpful for my students to visualize. So I'm going to say always start with 0 miles. And we know that when we get in it, we have to pay an initial $2 fee. So the cost is $2 for 0 miles. Then it says $1.50 per half mile. I get to choose what numbers I'm going to put in this table. So I'm trying to visualize what's going on here. So I'm going to say I just go half a mile. So I have to pay that $2 and then $1.50 for the half mile. So it's going to be $3.50. Then if I choose to go a whole mile, it's that much, but now I have to pay another $1.50, so it's going to be $5. And then 1.5, $1.50 more. 2 miles will be another $1.50. And then another half mile will put me at $9.50. So when I look at this, my starting point or my y-intercept was I start out paying $2. Then my rate of change, you need to be careful when you do this. Remember, your rate of change is your change in y over your change in x. It's usually going to read as your y per x, and it's going to be how many y's that happen per a change of 1x. So you may be tempted to write your rate of change as $1.50 per half mile, but that's not it. It needs to be per mile. So how much do we pay per mile? Well, if I were to do it to just 1 mile, I go a change in x of 1, and then my change in y is 3. So 3 over 1 gives me $3 per mile. So that per gives you a clue. You can also see if it says each or every, those are generally clues that you're talking about something that relates to the rate of change. Now let's make our graph. It tells us what x is, so the x-axis should be miles. And it said the y represents the cost. It doesn't say this, but it's the cost in dollars. Always be sure to include your units. I think whoever wrote this problem was just a tiny bit lazy when they were talking about cost. It should be cost in dollars. And you can always scale your graph however you want. Here's the deal though. You can't just put numbers on here. You can't say like that. You have to have each dash represent the same amount of miles or the same amount of money. And you need to have all the points that are in your table on your graph. So I'm going to make my miles, and they're just going up by 0.5s in my table. So to make it easy for myself, I'm going to have them go up by 0.5s here. But I don't want to write them all, so I'm just going to not write the 0.5s and just say, okay, that one's 1.5, but I'm not writing it. But this one is 2, so I'll just write the whole numbers. Okay, and then let me make this a little nicer. Okay, for our cost, we need to go up to $9.50. I have a lot of dashes here, so I'm gonna just make it so that I go every other for each dollar, so it's gonna be like 50 cents for each line. And because I wrote cost in dollars, I don't have to write the little dollar symbols on each of these little dashes, which should save you some time. And now I'm going to go ahead and plot my points. 0, 2 will be on the y-axis. Then 0.5350, then 1, 5, then 1.5, 650, then 2, 8, then 2.5, 950. So this line, it represents all the possible combinations for how much it will cost when I ride in this taxi. Now I'm going to write my equation. You already have your starting point and your rate of change. So this is your B and your M for y equals mx plus b. I want to give you a word of caution though, because if you decide that you're going to graph it and you're going to figure out the equation from your graph, you may be tempted to use a slope triangle. In this case, it would work because we have the same scale for both the x and y axis. But if we had decided to, like my miles are awfully squishy here, if I had decided to make it so that every mile was 4 dashes, then this wouldn't count as like 1 mile. If that makes sense. So you need to look on your axes in order to figure it out. It goes 5 to 6.50. So this is going up $1.50. And most of my students would count the squares. They'd write that as +3, but it's actually going up $1.50 because now our squares mean something. They're talking about a y value of dollars. So look at what the axes are and figure out how much it actually changes. And then 1 square is going up from 1 to 1.5, so this is going 0.5. And then when you divide, you put your change in y over change in x. But we found our equation. Here's what it is. And be sure to remember to write down that x equals the number of miles and y equals your cost in dollars. So how many dollars it costs. You can also do this without even doing a table or a graph, just by looking at the scenario. So I'm going to show you how to do that over here. Courtney has a coin collection. She already has 48 coins in her collection, but she plans to give away 3 coins each week. That each is going to come in handy because that's like a per, right? Like that probably means something to do with rate of change. If X represents weeks and Y represents coins, write an equation to figure out how many coins she will have after X weeks. Use the equation to find out how many coins she will have after 13 weeks. So I'm going to change back to blue here. Our initial point, it doesn't say it doesn't say starts with or anything like that, or it doesn't say initial in our problem. However, the earliest thing that we know about is that she has 48 coins in her collection. And then after that, she's going to give away coins, and that's when we're going to start doing our math. So our initial point is going to be 48 coins. So initial point is usually the point you start doing math in the situation, if that makes any sense. Rate of change is she's giving away 3 coins each week. I'm really tempted to say that's 3, but I'm not entirely sure. So I'm going to make a table real quick just to be sure. You don't always have to make a table, but this might help you out. So we're going to write our X as weeks and our Y as coins like it says. And I'm going to write just 0, 1, 2, just to figure out what happens. After 0 weeks of giving away coins, she has 48. Then after 1 week of giving away coins, she has 3 less than that. So it'll be 45. And then she has 3 less than that the next week. So it'll be 42. Okay, so my change in Y over change in X will be, it's changing by going down 3. So it'll be down 3 over plus 1. So my rate of change is -3. So it'll be -3, and I need my units here. It'll be coins per week. So it's kind of weird to talk about coins as being negative, but remember this is talking about a change. So that's just saying that it goes down 3 coins per week. Now we're going to make our equation with the data that we have. So y equals mx plus b, rate of change goes in for m, and then our initial value goes in for b. So that's my equation. Anytime it asks you for a specific number, you could make your table all the way out to 13 and subtract 3 each time. You could do that, and you've done that before, but that's a little tedious. So we're going to just use our equation, and that way we can figure it out. So it says weeks is x, so I'm going to put 13 in for x to figure out what y is. And I'm just going to enter that into my calculator to figure out y. And I did, and I got 9. So 9, be sure to interpret it in the context of your situation. So y equals 9, but what was y? Y was coins. So she has 9 coins after 13 weeks. All right, good luck.